Welcome back, dear children. This is part 5 of the series of lectures that I have prepared on solutions. In this, we are going to deal with osmotic pressure. The theory of osmotic pressure is as follows, that it and vapor pressure are closely linked concepts, both related to the tendency of molecules, particularly solvent molecules, to move from a region of low concentration to a region of high concentration. Vapor pressure and its link with osmotic pressure is explained as follows. Imagine a container with pure solvent like water. Some solvent molecules at the surface are constantly escaping into the gas phase due to their thermal energy or kinetic energy more appropriately, and back into the liquid surface. So there is an equilibrium between the molecules of the solvent, between its vapor and its liquid phase. The pressure exerted by these vapor molecules or molecules in vapor phase is called vapor pressure. As temperature increases, the average kinetic molecules increase, kinetic energy of molecules increase, leading to more escaping of molecules to form higher vapor pressure. Osmotic pressure and role of concentration. Now consider a situation with a semi-permeable membrane separating a concentrated solution having good mole fraction of solute in it and low solvent concentration from a pure solvent high solvent concentration, that is mole fraction will be 1. The membrane allows solvent molecules but not solute particles to pass through, and that is why a better term as compared to semi-permeable membrane would be selectively permeable membrane, because it is the membrane that allows the movement of particles, and the membrane allows the restriction or restricts the movement of other particles. Living membranes, that are membranes present in our bodies, the membranes guarding the cells in plants and animals both, they are highly selective. They give way to only those molecules which are required inside the cell and stopping the others from coming in. So they are selectively permeable, and selectively permeable is a better term as compared to semi-permeable. But the historical facts are there, and that's why we continue to use semi-permeable, keeping in mind that the membrane is selectively permeable. Now, due to vapor pressure difference, there is a natural tendency for solvent molecules to move from pure solvent side, that is higher vapor pressure area, to the solution side, the low vapor pressure area. The movement of solvent molecules creates a pressure inside the solution on the solution side opposing the flow of solute particles, and the pressure is called osmotic pressure. Oh, sorry, it's solvent particles, and the pressure is called osmotic pressure. The connection, essentially, osmotic pressure arises because of presence of solute particles in solution that reduces the effective vapor pressure of the solution compared to pure solvent. The greater the concentration difference between the two sides, more solute in the solution, the higher the osmotic pressure required to balance the flow of molecule solvent particles due to vapor pressure. The applications of osmotic pressure, biology, maintaining fluid balance in cells. If the outside concentration of liquids is high or solution is high, the cells will lose water and will become plasmolized. So the osmotic pressure of the solutions outside the cell and inside the cell must be almost equal, if not absolutely equal. Now, reverse osmosis. This is what is used to drive out the solvent molecules leaving the solid particles in that container through a semi-permeable membrane, of course, by applying pressure on the solution surface. So pressure here is applied on the surface of solution, which is in contact with its solvent, and the solvent molecules go in an opposite direction. And the pressure must be more than osmotic pressure. Science, understanding how sugar and other concentration affect the texture and shelf life of food is also there. Exosmosis is another term which is used, and endosmosis is the opposite term which is used. Exosmosis is the loss of water from cells due to concentration of solutions outside being higher than those of the cell sap. This leads to plasmolysis, and if it continues, it may lead to the death of cells. Endosmosis is the reverse, where the osmotic pressure of the cell sap is higher than the surrounding liquids outside the cell, and solvent molecules, water, is taken in through the semi-permeable membrane. Then we have isotonic solutions. Isotonic solutions, you see, isotonic is a relative term. If two solutions have such concentration of solutes that the entry of solvent from one to another and from another to the first one is balanced, then the solutions are called isotonic. They have equal vapor pressure and therefore equal osmotic pressure as well. So the solvent molecules, they neither move from the first to the second or the second to the first. Now, going to the quantification, let's see the quantifying osmotic pressure. Osmotic pressure is denoted by symbol pi. According to Van 't Hoff-Avogadro's law, osmotic pressure pi is proportional, directly proportional to number of moles of solute present in the solvent. It is inversely proportional to the volume of solution, because volume increases, the concentration decreases, so pi will decrease. If volume decreases, pi will increase because concentration will increase. So the first one, pi proportional to n, equation 1, that is Van 't Hoff-Avogadro's law. The second one, pi proportional to 1 by v, is Van 't Hoff-Boyle's law, and pi is proportional to t, Van 't Hoff-Charles law. Combining equations 1, 2, and 3, we have pi proportional to n by v into t. Replacing the proportionality sign with an equal sign, we get pi equals n by v into r into t, where r is gas constant, whose value is 0.0821 liter atmosphere, Kelvin inverse, mole inverse. From here, molecular mass of the solute can be found out easily as m equals w by m, where w is the weight of the solute and m is the molecular weight. So transposing m from that equation, we get m equals w into r into t divided by pi into v. I hope this will help you in solving the problems. If you get stuck in any problem, please comment, subscribe, and let me know of your difficulties. The solutions will be supplied straight away. Thank you for watching. Have a nice day. Thanks a lot.